Welcome to the Crazy Head Chemist. So another video in bonding and molecular structure. Bam! So today we're going to be talking about sulfur dioxide's molecular geometry and oh so more. So sulfur dioxide, what's the formula for sulfur dioxide? And that is SO2. We're going to get the valence electrons from our wonderful periodic table here in the background. That is 6 valence electrons in sulfur, 6 valence electrons in oxygen because they're in the same group. There are 2 oxygens. We're going to add these up here and then get the total number of electrons, which is 18. We're going to divide that by 2 and then we're going to get the pairs of electrons. How many pairs of electrons do we have? Are 9. The least electronegative element goes in the middle, and that is certainly the sulfur. Then the oxygens go around it just like that. Okay, now I'm going to place bonding pairs of electrons between the central element and the outside elements. Now I'm going to place lone pairs of electrons on the outside elements like that. Now, do I have any more electrons? Ooh, I do. So, those lone pair of electrons go on the central element just like that. Now, I'm going to verify or not verify the octet rule. I've verified the octet rule with the oxygen, so the oxygen is perfectly fine. Okay, now, the sulfur is deficient in an octet. So, being such and that I have used up all my 9 pairs of electrons, that means I need to move some. Okay, so I can either move one of the pairs, not both, like in carbon dioxide, just one of the pairs from one of the oxygens into the central element there between the sulfur and the oxygen to form a double bond, but not both. Don't do both, just one. Okay, and then you should get this Lewis dot structure here refined. You should see the sulfur in the middle, a lone pair of electrons right there on it. One of the oxygens is double bonded with 2 sets of lone pairs. The other oxygen is a single bond with 3 sets of lone pairs. Okay, we're going to get our axe-like structure from this. The central element is the sulfur. That's the A. There's only one A all the time. The X's are the outside elements. I see 2 oxygens, therefore it's AX2. I see a lone pair of electrons on the sulfur. That's the central element. So that's AX2 and then that E. And then from this, you should get the number of bonding domains and non-bonding domains on the central element. There are 2 bonding domains and 1 non-bonding domain. That corresponds to a bent or angular type shape. From that bent or angular type shape, we get our bond angle. And that bond angle is less than 109.5, which would be like about 105 for anything that is bent or angular. Okay, now we're going to do the next thing, which is our hybridization. That's sp1, p2. That's sp2 hybridized. Notice that a single bond counts as a domain around the central element. A double bond counts as a domain around the central element. And a lone pair of electrons counts as a domain around the central element. I only have 3 domains around that central sulfur. Therefore, it's sp1, p2 hybridized. Now I'm going to get the molecular geometry of this. Before I do that, I'm going to show you this molecule. Here it is right there. Check it out. That is bent in structure. I'm holding on to the lone pair of electrons. The tan in the middle, that is this one right here. That is the sulfur. And the green things are the oxygens in this case. Okay, is this symmetrical or asymmetrical? Does it have a bond polarity? It most certainly has bond polarity, that it emanates from the sulfur and goes to the oxygen. Therefore, the oxygen is more electronegative. That's why it's on the outside. Okay, and there is a bond polarity, so therefore this is an asymmetric molecule and it has bond polarity. This is most certainly polar, absolutely polar. Anything that is bent or angular is most certainly polar. Okay, that's another super cool chemistry video. And you get one of these hats when you go to this restaurant and it's your birthday. So, give me a thumbs up if you like that video. Subscribe to my YouTube channel and please pass on the word that this is the coolest place for chemistry videos. Bye now. So have a great day.